Hello, my name is Spencer Sheen, and this is a short tutorial on how to create a plot like this in R. And the reason that I think this is a useful tutorial to make is because you'll notice that this plot is showing two levels of grouping along the x-axis. So we've mapped these variables related to the bill size to the x-axis. So we have bill depth and bill length, and these are about penguins. But we've also mapped the penguin species to a higher level grouping, seemingly along the x-axis. And the key technique I've used here is I've faceted this plot, but I've hidden all of the usual elements of the facet. So there's no spacing between the panels. So this seems like it's a single plot. And the reason that this is beneficial is I think that faceted plots, to a non-technical audience especially, they take a little bit of intuition to understand them when you're first looking at them. In other words, there's some cognitive work that the audience has to undertake to ingest the faceted plot. They have to understand that there are these three panels here, in this case, three different species, one species per panel. This Adelie, Chinstrap, and Gentoo. I have no idea how these are pronounced, but I assume that's how you pronounce them. So they would have to understand there are three panels, and they would have to understand that the y-axis is the same across all three, and that they share an x-axis as well. And so there's all of that, which, yes, an audience can get past that, but we can also make it easier and more intuitive for an audience. We can take some of that cognitive load off of their shoulders, and that makes it a better data visualization. So hopefully I'm going to be able to get through this video pretty quickly. I don't want it to be very long. I want this to be a short tutorial, and I'm going to start from scratch creating this project. And this is going to be a bit of a live coding experience. So let's go ahead and get to work. I'm going to open up RStudio. I'm not going to update it. Let's see. All right, so first things first, I want to create a new project. Let's say we'll just do a new directory, new project. Penguins, facet, live coding. And I'll share this after the video as well. And I'm going to create a Git repository because eventually I'll connect it to my GitHub, and that's how I'll share it. And let's go ahead and create that. And again, remind me later. All right, great. So now we're in our project, and I'm going to create a new R script to get started. And you can do that with Control-Shift-N or Command-Shift-N on a Mac, and I'm on a Mac. So Command-Shift-N will open our new R script, or you could come here and select R script. In general, I'm going to assume you have your experience with R. I'm not going to cover all those little details, but I'll try to point some things out if I'm taking shortcuts. Now, this data set that I'm using here, looking at penguins, is coming from the palmerpenguins R package, as I point out down here. So if you haven't already, if you don't have that package installed, you'll want to install it with install packages palmerpenguins. And I already have it installed, but it'll go ahead. I guess there is a more updated version. Great, so now we have the package installed. Now let's go ahead and load it. Okay, and let's find that data we were looking for. I think it's the penguins data set. Yeah. Oops. going to use the tidyverse here, so I'm going to go ahead and be lazy and just load the whole thing. And now when I execute, I'm executing by hitting Command Enter. If you're unfamiliar with that, I'll be doing that throughout this video. And so this is the data frame we're looking at of penguins. So you can see here we have the bill length and the bill depth. We have the species also. So we can see that this is the data set that was used to create this graphic. So let's get started. First of all, we know that we are grouping at two levels. We're grouping at the species level, and we're grouping at the bill dimensions level. But because the bill dimensions are in two separate variables, that's not going to work out for us. So we need to pivot this table so that it's in long format. And we can drop some of this other data because we're not going to use it here. And so whenever I'm building a table, I like to first work with it without assigning it to a variable. Assuming it's not a massive table. This wouldn't work very well if it was a massive table. But let's select species, bill length, bill depth. Okay, there we're starting to get there. So really, this is all the data we need to make this graphic. So and like I said, we want to pivot this so that it's in long format. So we're going to use pivot longer. The columns are bill length and bill depth. There we go. So I did not assign what these columns would be called, and I'm fine with that. You could, well, I'll show you. We can also say names2 equals measurement, and values2 equals value. Let's say length, I guess. So it's different. There, and you can see our columns are now named that. Okay, so that is how we want the data. So now I'll go ahead and assign it to our variable. I'll call it long. And now if we pass long to ggplot, and we want to, again, we're at a basic level, we're assigning the measurement here to the x-axis and the length to the y-axis. And then we're creating a column chart, a bar chart. So if we do that, now we see where it's plotting something. But one thing I forgot is I didn't summarize this data at all. So right now, this is just a sum of all of those values. So let's also go ahead and group by species and measurement. And then we're going to summarize. And let's say average length equals mean length. So did that work for us? We had some NA values to deal with. So let's go ahead and take care of the NAs by doing NA.remove equals true. And there we go. Okay, so now we have each species has two observations, one for the bill depth and one for the bill length. And then we have the average values for those. Okay, so now we need to change this to average length. There we go. But it's still adding these because we haven't mapped the different groups to other sizes or to other aesthetics, I mean. So let's also assign, oh, my phone is ringing. Well, ignore that. So fill equals measurement. Okay. That's not what I wanted, actually. So if we look back at this, oh, the sex. I forgot about the sex. Species, sex. Group by species, sex. So now we also have the sex here. And let's remove these NA values because we can't compute those. Okay. And then fill is going to be sex, actually. There we go. Now this is starting to make sense. But we don't want the fill aesthetic stacked. We don't want the columns stacked. We want them dodged. And so, of course, we can do that with position equals dodge. And then the final piece we need to do, so right now this is combining all of the species in a single plot, but we don't want that. We want the species separated out. And like I said, we can accomplish that with facet wrap by species. And there we go. Okay, now we're making some headway here. Next thing I want to do is, so this is what I was talking about earlier. When an average user or a non-technical audience member would view this graphic, there's some work that they have to do to understand it. They have to understand that these are three separate plots, which might immediately, intuitively signal to them that it's showing different scales or different data without knowing it's showing the same data just for different groupings. So let's make it much more intuitive for them to understand. Let's hide the fact that this is faceted. Let's make it appear like it's a single plot. And let's move the titles closer to the x-axis so that they know we're looking at, for instance, chin strap bill length, the bill length of chin strap species. So first of all, let's make this theme a little more minimal. You can see what that does for us. And now we're also going to adjust several theme elements here. So I'm going to go through this pretty quickly. Panel grid, minor, blank. I'm going to get rid of all of those. And I'm going to run this with each item to show you what's happening. Panel grid major dot x. Oops. So that got rid of those vertical lines. So this is starting to look a little better. Now, the facet labels here, this is called the strip text. And let's see if I can remember how to do this without looking it up. Strip placement equals bottom. No, outside. And then it's actually within the facet wrap call. Here, there's a strip position argument. There we go. So you need to set, here, let me erase this. So if we just set strip position to the bottom, then it moves the labels from up here to down here. But you can see this is weird. This has put it between the x-axis labels, and we don't want that. And so that's why we say strip dot placement equals outside. And there we go. So now we have the labels down there below our x-axis labels. So that's cool. Now let's get rid of these, the space between the panels. Even though now this is a theme minimal uses, it's kind of hidden already, but let's go ahead and take it all the way out. And we can do that with panel spacing equals. So you can set whatever unit you want to use here since we're setting it to 0. But I'll just use cm, centimeters. So there we go. So now we've pushed these panels together so there's no spacing between them. And it looks like a single plot. Now all that's left to do is finish our formatting. So we've essentially taken care of the items that hide the faceting here. We moved the strip text down here, so it just looks like another grouping of the x-axis, and people aren't going to wonder why there are 3 separate plots or anything like that. And we push these plots together, so it just looks like a single plot. Panels together, I guess technically I should say. Next, let's move the legend position, so let's put that at the bottom. Let's take away, let's see, what else did I do here? We don't really need the fill label. We don't really need the X label. This measurement, I think it's clear to us that these are measurements. Okay, that's looking a little better. Now to update these labels, what these actually read as, my go-to technique to this is just to mutate the data itself before the data is passed to ggplot. So that's the measurement. And there are only 2 options here, so we can use if-else pretty easily. So if it measurement equals bill depth, then our yes condition is going to be average bill depth. And I'm doing a line break here so that it cuts it to the next line when it's plotted. You could also do that by wrapping the labels, but sometimes I prefer to do it this way. So the no condition is going to be the bill length. So average bill length. All right, so now that's looking pretty good. And then our Y label, let's call that size in millimeters. Okay, what else have we done over here? So let's make this size bigger. And we can do that with strip.text element, oops, I always do that. Element text, size equals, I don't know, what do you think? 20, face equals bold. Oh, strip text isn't a thing. Huh. Wait, strip text is. The strip text theme element is not defined in the element argument. Ah, you're probably screaming at your computer. There we go. Not stip text, strip text. Come on, Spencer. Okay, so now that is clearly delineating that this is the higher level grouping here. So when a user looks at this, they're first going to see that this is grouping by whatever this is. We assume our audience will know that these are penguins. penguin species. And we can signal that with the title also. So comparative bill sizes. And subtitle equals, I'm just going to crib what I already have here, which I think I actually borrowed some of this language from the Palmer package anyway. That documentation. Yeah, there we go. A couple other formatting things I want to do. I want this text is aligned to the panel. I want it aligned to the plot. So title, title position equals. I feel like that's wrong. Yeah, what is this called? Plot title position equals plot. There we go. So now we can see this is moved over. Let's also plot title equals element text, size equals, let's set it to 44. Let's also make the face bold so that it really jumps out at us. Let's add some margin between that. Let's add some space between that and the subtitle. Margin equals margin. Bottom equals 20. There, and there's a little space. Now let's make some updates to the plot. Subtitle. I'm going to make this a slightly different color so that it's kind of lower in the visual hierarchy. And let's make it gray 30. If you're unaware, a neat trick is that you can assign a color gray and then with a number suffix all the way from 1 up to 99, I think. And anything higher will make the color closer to white, and anything lower will make it closer to black. So there is, so now we can see this is a bit grayer than the normal black here. We see this is going off of my plot here, but I'm okay with that at this point because I'm going to save this to a PNG file, and the file, that image is going to be bigger than what this is, so it'll fit. I also want to add spacing between this and the plot. So margin equals margin B equals, let's do 20, the same. There we go. Now everything's breathing a little bit better. I just realized female and male here are not capitalized, so I'm going to use the same technique I did up here. There we go. The last thing I want to add is a caption that really just provides this data source. But I also need to account for the plot caption. I'm also going to align that with the plot. Plot caption. Plot captions by default are aligned to the right, but I want it to be aligned to the left, which you can do with hjust equals 0. I want this text to be even lower on the hierarchy, the visual hierarchy, so I'm going to make this a little wider by going with gray 50. And let's see, I made the subtitle size 18, so let's make this size equals 12. Let's see what that looks like. Okay, this is looking pretty good. The only other thing is to assign these colors if we want to match these colors. First, let us save this. So let's create a plots folder. Let's go ahead and save our script too. So we'll create an R folder, and Command S will help us save this. And I'm just going to call it main. Okay, now ggSave will save our file. It will take this last plot here and save it to a file. So let's say, let's call this, we're in the plots. We want to save it to the plots folder and call this, I don't know, final plot.png. Let's make the background equals white, and let's see how that shows up. Okay. Now, it appears that I lied to you. I said this text would be fine once we saved it to our image, but I'm wrong. So the text has gone off the screen. So we could either wrap that text, or we could make it smaller. Let's try to make it smaller. All right, let's go down a little bit more. And this is nice working on a Mac. I really prefer building plots on the Mac to building plots on a Windows computer, because I'm able to keep this preview open, and every time I switch back and forth on my screens, the preview will just update. I don't have to deal with closing the window or anything. I just realized I have a bracket here and a parentheses here. That's not what I want. There we go. All right, so there is that. And I will tell you, I got these colors from the palmerpenguins package itself. So let's look at the penguins. Let's see. Well, let's look at the documentation online. palmerpenguins. I'm going too fast, aren't I? So palmerpenguins, and then Allison Horse has a website created for this package. And then you can just go through, and I'm looking at the code, trying to find the colors. Where have the colors been defined? That's not going to work. What about... No, so there's no hex code defined here. Examples using ggplot. Here we go. So these are the dark orange and the cyan 4. Those are the colors I chose. So we can set the colors with scale, fill, manual. This allows you to pass a set of values, which are either the names of colors or hex codes of colors. And I already forgot what I said. So dark orange and cyan 4. Cyan 4. And there we have it. All right. So final piece here that I just realized. So now we have this appearing as if it's a single plot instead of 3 separate panels. But when we did that, this is kind of smushed, and I think it would be clearer if we added a little spacing both between these and between the individual panel bars. So between this one and this one, for instance, and between the panels themselves, while also maintaining the single plot appearance. All right, so let me show you what I mean by that. First, we can set the width to the width of the columns. Let's make it a little smaller so that there's more breathing room between them. Let's try even 0.5. Yeah, there's a lot of room. And if I go ahead and save that, we can look at the full. So now we can see there's a lot more room there between the plots, but it's not clear that these two are grouped together as a single species. Aside from this text below it, let's make that clearer by bunching these two sets of columns, by bunching each of the sets of columns. And we can achieve that effect by expanding the x-axis on each panel. And you can do that with scale x discrete. This is a discrete x-axis because it's single values. It's not a continuous numerical scale. So scale x discrete, expand. There's this expand argument, and you pass two values to it, such as 0.5, 0.5. So this is going to create additional space or less space, depending on how you set it, on the left and the right of the whatever axis. So here, the x-axis. And so we can see that added additional space. And now these plots are clearly, this is very clear that this is one grouping, this is another grouping, and this is a third grouping. I actually think I made these bars a little skinny here, so I'm going to go back to 0.75. Oops. 0.75 width on geom column. And there we have it.